once you know a little bit of statistics, and it's apart from that, there's nothing else in Monte Carlo. You just need to get familiar, and people unnecessarily fear the name Monte Carlo for a variety of reasons. Sorry, I was laying this time because I had a session today as an IP. Let's let this out. So now, what Monte Carlo does, I tried to, there's other session that I've already taken for BBA members, where a lot of theory I took in, and that video is available in the YouTube. So I thought when Asim reached out to me, he said everyone wants more practical, more easy to execute stuff than actually want to hear any theory. So yes, that video is available. So I'll try not to go to a lot of theory. I try to give it an experimental basis how to use it. Once you know a few things, then you're good to it. Thereafter, for you, you should know a little bit of theory behind it. And that is something, there's a YouTube video of mine only in the YouTube. So you can see that. There are plenty of videos in the YouTube where you can learn as well. So I will not go into much of theory. It's more of a Excel-driven learning through and actually implementing various stuff. Lastly, it's preferable if some of you are also using computer along with me when you're doing it. It's easier. At least some of it you can actually try it out so that you get comfortable while you are listening to me whenever we are doing the examples. So let me open my presentation. So how since it is from ICAI, I'm sure all of you are primarily chartered accountants. I mean, that's why this group is. How many of you are familiar with basic statistics? Anyone would like to say basic statistics? No.
Basic statistics as in correlation, regression.
Okay, fantastic. That's good. That's not basic.
Deviation, probability.
Probability. That's good enough. Once you know probability, you're good. So I think the Monte Carlo is less of finance. It's more a mathematical approach to what you're doing. Monte Carlo model, rather it is very interesting for me. I always say this, even in my other presentation, I say, whenever we want to scare someone, a fellow audience, we just have to say, "Kya tere ko Monte Carlo aata hai kya?" As if it's like Gabbar aa jayega kind of stuff. Sholay movie. Everyone fears this name for a variety of reasons. And it is such a simple thing. It's so easy to execute, actually. There's nothing behind it. It's actually, if you were to go pure theory part, it's very complex. It's a mathematical complete distributions. But when we are on the application side, when we are largely into trying to look at some rationale, it becomes easier for us to use it, Monte Carlo, for a variety of purposes. Second thing is, Monte Carlo does not give you a single value. This is something you should go out. Yes, some places we can just take average. It actually gives us the range. And what we are telling is with what confidence you are going to come with a value. So for example, I say, okay, what is the value of this company? I say with 75% confidence, I say this is the value, or 80% confidence. Monte Carlo talks about that language of the confidence level. So which is something, again, we'll go through it. And wherever you get stuck, hear me out, please. Wherever you get stuck, ask me. What I know, I will share. What I don't know, if I can get back to you after going through something, I'll do that. My information is largely from the public domain. There's nothing new, but I've read a lot around it to give presentation to people like you. So let's start the presentation. I need to share. Do you have a right to share, please? Do you have a right? I don't.
You don't have them yet, is it?
I think share screen is there. So 1 second. Let's figure it out. So, can you see the screen?
Yes, we can.
Yeah. So the previous presentation that I presented earlier, but I modified for the purpose of you guys a little bit. And we'll go largely through Excel. PPT has this many slides. Don't get scared. I'm not going to use all the slides in this again. To start with, the expectations. This is an absolutely trying to be a practical oriented session. People with computer in front of you, it will be easier if you're using it. You'll be able to use it, at least attempt to use it thereafter. There are various data distributions That's a lot of theory around it. This presentation will have it. However, I'm not going to go through a lot of distributions here. I'll go high level and start using it for our purpose. We need to simulate it. We will know how to simulate it and some data distributions. Let me do the acknowledgements because we need to acknowledge the sources. I would like to sincerely acknowledge that all the material that I'm presenting below is from various sources available in the public domain. And I would like to specially acknowledge Professor Ashwin Damodaran, Professor Nicholas Vittal, Excel's Fun YouTube videos, and many other videos actually, not just limited to this. Okay. Whenever there is an uncertainty, we all know what's an uncertainty, right? In management, we say uncertainty is risk, right? So whenever there is an uncertainty, what do? We put a value to it, right? There's a 10% challenge, the risk is there, 15%. How do you know it's 10%? How do you know 15%? Then will you say, hey, listen, okay, the risk is not 10, 15, it is say 10, 12, 13, 14, 15, 5 numbers. It's still easy. In mathematics, we have, in Excel, we have easily what if scenarios. Put each number for 10%, 11% to 15%, try to plot, get a value. And then what do? We do an equal weightage or we vary the weightage. And depending upon the client's requirement, we just use the method to come to a valuation, right? That's what we do. So when you don't know that it is only 10, 11, 12, 13, 14, it is anywhere between 10 to 15. It could be 14.5, 13. The number of scenarios goes up. What ifs becomes a challenge. Then how do you predict? How do you predict a sales growth rate between 15 to 20%? How do you know that this is 15 and this is not 20? All such things. Monte Carlo simulation is actually repeating this experiment that many number of times. Whatever input variables you want it will do that entire repetition so many number of times that you want in eventually to come to the desired value. So Monte Carlo comes with the output. Then what you do is you get the output. You then decide at what percentage confidence I can say that this is the growth rate. And based on that, you do the valuations or you do the estimation, you do the project planning, you take the business decisions. So there are various advantages, and primarily because if there's no uncertainty, you don't need a Monte Carlo. So if there is no uncertainty, there's no Monte Carlo. Monte Carlo is used only because you have uncertainty. You want to actually try it out by repeating the experiment. So now I'm jumping all this and directly getting into the fewer slides. It's a type of simulation that relies on repeated random sampling and statistical analysis to compute the results. So I am asking you, how many of you have understood this statement? What is repeated random sampling? Essentially, we are saying that if once we say it's a 10% growth rate, we come out with an output, what will be the free cash flow of the company? Then we say, no, it's not 10, it's 10.1%. We again do the free cash flow calculation. Then again, we say growth rate will be say 12%. We do the free cash flow estimate. So each one percentage that we input and get an output, we are talking about it is a repeated way of getting the output. Only thing is, this is random sampling. So I am not trying to infuse my data. I want 12. I am asking the system to throw the number randomly and give me the output. And that's exactly what we mean by repeated random sampling. The word sampling is essentially emanates from the point of the population. In statistics, we use the word population. Population is, suppose if there's an entire telecom market is say $1 billion market. That is the population. But however, we sample a few. Take the best example is politics, right? We all have these exit polls and all the predictions. It's not that they're going to every person who has voted to check it. They're taking a sample of it and making a prediction about the likely estimate of who's going to get how many seats, who's going to win. That is nothing but using a sample, you can make an estimation. And that is completely statistical in nature. So once we get the output, we can actually do the statistical analysis. What do we mean by statistical analysis? I did a estimated 10%, 10.1%, 11% growth rate, 12% growth rate, all the way till 15% growth rate. I did some 10,000 times. I don't know what number. It automatically picked up a number. That number, what I get as an output of the valuation of the cash flow or the revenue, I can average it out. I can see what is the mean, what is the median, what is the standard deviation. All that can be done from the statistical analysis. Please stop me for any terms that I'm using, because I will not be knowing whether you have followed that term or not at various points of time. So the Monte Carlo method is computerized mathematical technique that allows people to quantitatively account for risk in forecasting and decision making. So first of all, while we say it's a computer, the moment we say it's a computerized technique, that means there's an algorithm in the computer, right? There's an algorithm. That means there's an inbuilt input that the people, we have humans have given to the system. Therefore, to that extent, it may not be pure play random by nature, like throwing a dice. When I throw a dice, it's completely random. But when you use a computer generated random sample, it is not an absolutely random in nature. So it's called a pseudo random generator. The word pseudo is because it is actually random. Largely the computers, Excel and all, they've got a good systems in place. But still, because it is driven by an algorithm behind that particular program, we call it a pseudo random generator. So it's a mathematical technique that generates random variables for modeling risk or uncertainty of a certain system. The random variables or inputs are modeled on the basis of probability distribution. So I have skipped all the slides earlier. Probability distributions, some I'll come behind later also. So essentially what we are saying is, when we have what is that outcome we will expect at various probabilities, that's a probability distribution. So this entire random variables or inputs are modeled on the basis of probability distributions, and various ones are normal, log normal, etc. Most of the time, very conveniently, in industry, across professors, academics, they use normal distribution. Normal is the most easiest, convenient, and there are theorems that have been built around that, mathematically saying that even if an individual data distribution does not follow normal distribution, the means of the data eventually tends to follow normal distribution. That is the power of normal distribution. How many of you are not familiar with normal distribution? Or how many of you are familiar with normal distribution?
Familiar, sir, familiar.
It's a bell-shaped curve, right?
Yes.
Fantastic. So what is a standard normal distribution? Anyone? So in a normal distribution, you have a mean and a sigma, and a standard distribution, normal distribution, the mean becomes 0 and the outliers will be 1. So that's essentially the standard part of it. So we'll also be using in the random walk theory later about that. So now we'll come to the what is it that we are differing here. In the traditional what if model, we have an input data. So we say that the company is going to grow at 10%. We apply a particular formula in a free cash flow, present value. We have the free cash flow from operations. We have all the free cash flow calculations, and then we have an output. That leads to whatever is the base case for us. And then what we do typically, we do a worst case, we do a best case, we get a 3x3 matrix, and then we do a averaging it out. And that's exactly what we do in a traditional model. We don't know, is worst case is the worst case, is best case is the best case, and whether all the input parameters simultaneously behave. Because if my input of all of you I'm assuming are also valuers, am I right in that statement? Valuers, right? Mostly?
Yeah, most of us. Yes.
Yes.
So when you do a free cash flow calculations, you have sales, you have gross margin, you have fixed cost. So you have various input parameters, right? So the traditional math model, each parameter can behave differently along when others are not there. So we cannot really do so many what ifs, but we live with that. And this is what has been used earlier, because earlier computer power was not there. Now with the computer power, we are able to do more simulations. So what do we do in Monte Carlo? So we identify statistical distribution for each of the input parameters. So why do we say we identify certain distribution? So what happens is, lot of empirical data and academic reading has happened. They have come out whether it's a binomial distribution or a normal distribution. If a particular data follows a pattern of a distribution, then I don't need to worry about the properties, because someone had defined, if it is a binomial distribution, the mean value is number of trials into probability of success. The variance is number of probability trials into probability of success into probability of failure. It's a defined property of the distribution. So I know that if it's a binomial distribution, I can use those properties. If it's a normal distribution, I can use those properties. What is the property of a normal distribution? Between 1 sigma, I have 68% of data satisfying my requirement. Between 2 sigma, around the mean, I have 95% satisfying. Between 3 sigma, I have 99.95% data satisfying. What are they? They are nothing but the properties of that particular distribution. So when we have a data, and that data is something, if we can link it to a particular distribution, then we are in a good status, because we are in a comfortable zone of using that particular properties of the distribution. So we identify first a statistical distribution for each of the input parameters. Thereafter, once we have it, we do a random samples from each of the distribution. I'll show it to you how do we generate random sample. And once we generate, what are we saying is, so I'll do a random sampling for sales. Sales follows a particular distribution. I'll do a random sample for a gross margin that follows a particular distribution. I'll do a fixed cost, a particular. So each of this thing, I'll generate randomly one number. When I generate, all these come out, give me a particular free cash flow. Based on the free cash flow, that's my output. So now I repeat again. I again do another sales, another gross margin, another thing. Again, that second set, I get an output parameter. Like this, I repeat. The number of times I repeat, to that extent, the model is so powerful by nature. There is also, I think, a formula, how many times you need to simulate. I think 2 by sigma square root of n or something. I think we can see that later. So once we get this output, that is when we actually start analyzing statistically, what does this output tell me? Because finally, it's all about interpretation of the output. Once we know what we can talk about the output, that is what we can use it for our day-to-day business purpose. Any questions till now? There are 2 kinds of distributions. One is a discrete distribution. One is a continuous distribution. How many of you have heard about this? Discrete distribution, continuous distribution. Anyone has heard about it? Discrete distributions are essentially when the random variables take only discrete values. For example, when I throw a die, 1, 2, 3, 4, 5, 6, there are specific values that I can pull out in a discrete distribution. In a continuous distribution, I can get any number. Suppose if I say sales growth follows a continuous distribution between 10 and 15%, then it could be 13.917432. It could be 14.72145. It could be any number so far, so it is difficult to count. So continuous distribution is a continuous curve. That means the probability of any specific value is 0. So for example, what is the probability of sales growing at 14.92734%? It will be infinitesimally small. That is almost equal to 0. That's why it's continuous distribution. So it can take any number from 10% to 15%. Whereas in a discrete distribution, I have a specific value. When I throw a dice, it can only take 6 values. So it's easy for me to say it's a discrete distribution. So a normal distribution or like continuous distribution and a binomial distribution is a discrete distribution. So I talked about sample, random number generator. So these are the sequence of steps. So we do a static model generation, we identify input, and then I'll start taking you to various Excel files now, because that's the objective of doing this. So we'll go to the Excel files. The garbage in, garbage out. One has to know that in running a simulation, you are trying to estimate an output variable using similar. So if you give an input incorrectly, suppose if the input you have taken as a normal distribution, but it is a binomial distribution, or if it is a exponential distribution and you have considered as a Poisson distribution, then it's a problem. So if your input data is wrong, output will be wrong. So it is applicable for real option. Real option is a completely different concept. We can discuss it later. Portfolio analysis, option analysis, and person planning. This is a little bit of theory that I wanted to go through. Now, how many of you would like to see a basic slides of each distribution, or you directly want me to jump in the Excel file? You should understand basics, one pager, each distribution. You're familiar with all these distribution, binomial, Bernoulli, Poisson, hypergeometric, geometric. Should I not?
No, we are not familiar. So maybe if it's only one slide, you can, go ahead. Yeah.
Each distribution is one slide.
Yeah, that's all right. Yeah.
Okay. So what is a Bernoulli distribution? So Bernoulli distribution essentially is it's actually a binomial experiment of either it can happen or it will not happen. That's all. So Bernoulli distribution is either the probability of success is there or not there. So when a contingent liability is there, either the liability is going to happen or it's not going to happen. So this is what Bernoulli experiment is. So then the expected value is therefore the probability and the variance. So let me give an example of a Bernoulli experiment. So a company has a litigation before civil courts, and company is currently in the expansion phase. So it will have a problem of the cash flow, reputation, everything if the results come in now, but after 2 years, company feels it has no issues. These are all simplistic way of I've put it up for explanation for our purpose. They could be much more complex in nature in real life. So company says, beyond 2 years, the company's cash flows will stabilize and has the ability to withstand the potential liability due to adversarial judgment. 2 saal tak I have a problem. After 2 years, I don't have much, I can manage. That's the requirement. For simplistically, I said that the probability of the judgment coming in over the next 5 years is equal. Har saal mein 20% probability hai. You all understand what is the probability? 20% aane ka hai. So what happens is probability that the judgment happening is considered as X. When I say P of X is the probability of judgment happening. Probability of judgment happening greater than 2 is after 2 saal ke liye probability kitna hai? 0.60% hai. Probability of the judgment happening within 2 years is how much? 40%. Therefore, expected loss. अगर मैं बोलूंगा 2 साल के अंदर मेरा 10 लाख का लॉस हो जाएगा और 2 साल के beyond it's 5 lakh loss, then the expected loss is 7 lakh. So if I were to record today based on this outcome, what is the loss expectation I would record or I would plan myself or this thing? It's around 7 lakh in the contingent liability. So this is how Bernoulli experiment. Bernoulli experiment is जहां भी आपको लगा कि सिनेरियो एक ही है या सक्सेस या फेलियर बस वही है, that is the time you use a Bernoulli experiment. ठीक है, it's such a simple thing. Now Bernoulli के बाद जो binomial आता है, अगर यही Bernoulli को मैं 100 बार करूंगा वो binomial हो गया. जो Bernoulli एक बार किया तो Bernoulli है. So 100 Bernoulli experiments is one binomial distribution. 1000 Bernoulli experiments is one binomial distribution. So जब repeat करता हूँ, that is nothing but the binomial distribution. What is binomial distribution? Binomial distribution measures the probability of the number of successes or failure outcome in an experiment in each try. तो मैंने इसको 100 बार ट्राई किया. कोई भी let's take example of a dice. मैंने एक डाइस डाला, नंबर ऑफ एक डाइस के ऊपर 6 नंबर होते हैं, 1 2 3 4 5 6. प्रोबेबिलिटी ऑफ नंबर ऑफ 1 कमिंग इज 1/6. तो बोला मुझे नंबर 1 चाहिए होगा, तो मैंने पहली बार डाला नहीं आया, दूसरी बार डाला नहीं आया, तीसरी बार आया नहीं आया. सो द प्रोबेबिलिटी ऑफ द नंबर ऑफ सक्सेस और फेलियर इन ईच आउटकम इधर प्रोबेबिलिटी तो 1/6 है. So what binomial distribution says is when the experiment has n trials and only 2 outcomes are possible, success or failure, then the probability of success is P, the probability of failure is 1 minus P, and her trial independent agar hota hai, then we have something called as a binomial distribution. So given this distribution, let's try to do some problems. Can someone see the binomial distribution Excel file for me?
No, Ganesh, you will have to, first unshare this particular screen. Then you have to reshare the Excel sheet. Then only we will be able to see it.
Sure, I'll do that. Anyways, Prinesh has asked me 431, please explain basics. Prinesh, you need to come back because I started asking this question, how many are at what level for me to take a call.
Ganesh, I think Prinesh mentioned when you were asking whether we should go through those individual slides, that's when he had put that message. So we are through that, yeah.
We are through that, right? Because it is mathematical also. I don't know how many of you are comfortable. Then that's why I'm quickly getting onto Excel file, because that was a deliberate attempt so that, through experiment, we can actually learn for you guys. See, binomial distribution, there is a function in Excel called binom.dist. The other function binom.dist.range, which gives in the range and all this stuff, that you can do it on your own. I've used a simple function binom.dist. What essentially is binom.dist is saying, when I have a large amount of data available, whenever I use the word data, it is simple. It is say that the number of people voting in a particular constituency, that is a data. The age profile of a school, that's a data. So when I have a large data, the daily sales of a company in finance, that's data, right? So when I start plotting the data, that is nothing but distribution. What I'm doing is I'm classifying what is my sales. Suppose if I'm in a restaurant, if I'm in a retail business, I'm a supermarket. My per day sale is 1 lakh per day. Tuesday I got 1.2 lakhs. Saturday, Sunday I get 2 lakhs per day. I get a lot of data, right? Then I can actually classify every Monday how much of sales I do. Every Tuesday how much of sales I do in a year based on the data. Then I can actually do the analysis. This is nothing but data distribution. You're actually plotting the data and trying to distribute under various frequencies. So binom.dist is nothing but that particular data. If it has a property of a binomial distribution, then we use a binomial distribution function. What do we require when we want to use a binomial distribution function in Excel? We need a number of successes in trials, number of independent trials, the probability of success in each trial, and a logical value that determines the form of the function, whether it's a cumulative function or a non-cumulative function. So let me explain to you what does this mean. Suppose in a binomial distribution, if you're following me, I have two extremes. I don't have a probability. I have a probability of 10% something is happening. I have a probability of 20% something happening. I have a probability of 90% something happening. This 10, 20, 30, 90, I am getting into the cumulative function, cumulative distribution. But when I take individually a specific property at a particular point, that is a non-cumulative function. That's why this use the word cumulative. In Excel, we can use, if it is true, it's cumulative. If it is false, it is not cumulative when you are using the function. So I'm going to show you the function and then you'll understand it better. Okay, everyone, can we see the screen for me here? So binom.dist. Can you see this function? These are the 4 functions. Number S.
Yes.
Trials. How many trials I have done? Probability of success and cumulative. Probability of success, the sample. So let me take the first problem for you. And through that problem, I'll explain you this particular function. A company in the business of manufacturing toys to decide to use online e-commerce facility to expand its sales. This is all cooked up stuff, so don't catch me in something just for easy. I just try to do it. The company has been historically growing at 15% per annum. The company targets to grow by 20% due to the new avenue of sales. The company approached leading e-commerce player. I don't know whether whether I put that here. Let's see which one I've done. No, I've done something else here for you. I'll do this. I think I copied something else for problem for you. This is the one. Okay. This is the problem, the third problem I'm explaining here. Asim Mankodi wanted to conduct a seminar. He says the cost of the seminar is $3,000. In the seminar, you will have an audience. And he believes that I will be able to at least get one customer by that seminar, or number of customers I can get seminar. The average commission for the new account that I'm supposed to pay is 4,500. Number of people who attend, when I say number of people, it is 35. So this is what I have as the number of people who is attending the audience, number of trials. What is the success I have? I have only 4% success. That means if 35 people are attending, I only have a probability that ability to get one new customer is 4%. Correct? Now, if this is the case, what is my typical profit? My profit is essentially nothing but, you can see it here, formula. My particular value, which is your number of success I have, into my commission that I'm going to make, minus the cost that I'm incurred for particular conducting the seminar. Simple. If I'm able to convert one customer, the revenue from that customer I get, minus the cost that I've incurred for that customer is my profit. Right? So now, when I see this number, I say that, okay, now I need to see, I don't know with certainty whether the probability is 4%. It can vary. No, I have the distribution is, I have a 35 trials. I have a probability of 4%. How many successes I will get? It follows a binomial distribution. Because it follows a binomial distribution, let me see simulate a scenario, how many I will get it. Given the successes of n, the probability of randomness, and therefore the given the average success is 4%. This is the average success. This is the trials. So now I have estimated the reverse function number of successes. This is nothing but I am trying to simulate now. If I were to do this, let me just plot it here. If I can help this. Number of trials, probability less. See here, this is 58.9%. This is nothing but the distribution which is giving to me when I am using a binomial distribution function. The function that we are supposed to use in Excel in a Monte Carlo approach requirement is an inverse function. So I am trying to reverse calculate. I'm going to put a probability and to determine how many successes I'm going to do it. Here I have given a success of 1 year. How many of you can see my cell? Can you see this, or should I zoom it?
We are able to see. Yeah, that's fine. Yeah.
See, please understand. If I have a success of, again, I'm repeating here for the sake of it. When I'm using a distribution here, number S, that is number of successes. I'm saying my number of successes is 1. Out of how many trials? I did 35 trials. Then I said, what is the average probability I have? I said it is 0.04. And I said, I need a cumulative distribution, true. So this gives me 58.9%. So this is the distribution I'm getting in. So suppose if I say my number of successes is 2, my distribution is 83%. That means given this percentage of probability of 4%, I have 83.6% confidence of only 2 success. So if I want 3 successes, I have 95%. So this is how the binomial distribution, this is a complete statistical distribution. So I'm using the properties of binomial distribution. So now that I know this follows a binomial distribution, I'm using the inverse function. I'm using the inverse function to determine the number of successes given a probability. Given a probability, I'm using a reverse function to calculate. Here I've inputted the number of successes, 1, 2, 3. Here I'm calculating the number of successes by inputting the probability. How do I input a probability? That is what is actually this entire game of Monte Carlo. There's something called a function called as RAND. How many of you heard about the RAND function in Excel? Anyone heard RAND function? RAND function is essentially a random number generator in Excel between numbers 0 and 1. It generates a number. That's Excel. It's a pseudo-random generator, right? Probability is also 0 and 1, right? Probability is also 0 between 0 and 1. Therefore, what it says is probability distribution. I am going to input the probability distribution by using a RAND function. So once I am inputting a random probability distribution function, given the properties of that particular distribution, in this case binomial, which requires number of trials and the probability of success. If I have those two, if I'm inputting the probability distribution value by a random number, I will get the number of successes by using the binom inverse function. This is an inverse. Binom distribution gives you the probability distribution. Binom inverse gives you the number of successes because you are inputting the probability. I'm going to pause here. I'll ask you, did everyone understand? Because this is the same theory I'll apply for every other distribution. That's why I'm asking this question. Anyone understood it? I need to repeat it. Because if everywhere I'll be using the same thing. Silence is golden.
Hello.
Yeah.
So I have a question. Did you assume a probability of success, or this is something which is an assume? So
No.
how did you derive this 4% as a probability?
This is the input. If you are running a business, these are your input. Because I said to you, you have an input of 4% success, and you have tried a 35% trial for a 35 trials. So now we have, if this follows a binomial distribution, you need these two. That's the requirement. And the assumption is all are independent trials. Every customer acquisition is independent, right? So there is not be any dependent. Once you have assumed these two, then you can actually create a binomial distribution for each one. For example, I'm just putting a number for 0 successes. But I have not had any success after conducting the event. Asim Mankori failed. He has conducted an event. He has failed. So what is the probability that there will be 0 successes? I have a 0 success, which is 0. Number of trials is how much? Number of trials is 35. Then probability is how much? 4%. And for easy to understand, I'm using false. False means it is the specific probability for the event equal to 0. I'm putting a false here for a second. And allow me to do one more thing here. I'm again doing a binom distribution. Going again, number of successes is 0. Number of trials is 35. Probability of success is 4%. And I'm doing a false. Right? The first one, it is same, right? Because first one is nothing but P of X equal to 0. But no successes. We are saying that our success is 0 after the event. The next one is I'm going to do X equal to 1. I'm saying that exactly 1 success. Give me the probability of exactly 1 success. That means I'm going to do a binom distribution of exact success of 1 for the number of trials of 35, for the probability of 4%, and I'm saying again false. What I'm saying is this is the exact probability of one success. In statistics, it's also called as a probability mass function. So the probability of one success is 34.9%. If I were to make this as a percentage, hello, tell me if you're able to see this number. This is 34.94, exact success. Now, here I'm going to insert something here. X is equal to 0. And here, what I'm going to do is, I'm going to call it as X less than or equal to 1. Because now it is cumulative. When I say less than or equal to 1, I'm saying that the probability of 0 or probability of 1. What should be the value here? Anyone can give me a number for me? What should be the value here? Anyone? If probability of 0 is 23.96%, probability of 1 is 34.94%, what will be the probability of X less than or equal to 1? Anyone? Don't want to try? Let me be very honest. First of all, this is the statistical stuff. This is the stuff where everyone fears. And moreover, you are also not going to respond to this. It will be difficult, right? How will I know whether you understand? This is not some theoretical stuff, right? I'm assuming you will respond. If you don't, it's okay, we're all learning. The probability of less than or equal to 1 will be nothing but probability of X equal to 0 plus probability of X equal to 1. Am I right or wrong? This will be the value ideally. That means if I add up these two, I should get the number 58.9%. So let me see this. When I do a binom dist, number of successes 1, number of trials 35, probability of success 0.04, and I'm saying cumulative is true. What did I get? 58.90. If I add these two, I get 58.90. Now, thanks, Pratik. Now here, the reason I said this is it is going to add up because I'm taking cumulative. The right side is nothing but cumulative density function. This is a specific probability density function. Again, don't get confused if you're reading anywhere. If it's a discrete distribution, they use the word probability mass function. And if it's a cumulative mass function, and if it's a continuous distribution, they'll use the words probability density function and cumulative density function. The word density is used for continuous distribution. The words mass is used for discrete distribution. Again, I started saying there's a lot of theory here. You should have a little bit of understanding of stats. It is nothing but completely a distribution, a data distribution, which we are going to use it. So here, now we know that if I want to do a successors of 2, then I just have to do a probability of, so I do a binom distribution of number of successes is 2, number of trials is 35, probability of success is 4%, and if I want to do a specific probability, it is 24 false, I will use it. And here, if I want to do a cumulative probability, which is less than or equal to 2, I'll just do a binom dot dist coming, number of successes is 2, number of trials is 35, probability is 4%, and this is true, I get this. So what does this data tell? What it is telling is, if I have 35 tries, and if I have 4% probability of success, that means the moment I acquire 2 customers or up to 2 customers, 83.7% chance is over. I cannot acquire more than 83. I put effort of 83.7%, I get 2 people as success. That's what this tells you. Now that we understood this is binomial distribution, now remember, I have inputted 0, 1, 2 here to determine these percentages, right? I now do the exact reverse. I'm going to input these values, which is nothing but your probabilities here, and then calculate the success. So let me do this effort. Let me do one. I'm doing this, carefully see this here. Binom, let me do it against this so that it becomes easier. I'm going here. Carefully see this. Binom dot inverse. Earlier I did a binom dot distribution where I've given the input of number of successes to determine the distribution probability. Now I'm doing the reverse. I'm doing the inverse. Here, what will I get the first input? Number of trials. Fantastic. What is the probability of success? 0.4%, 4%. And then alpha. Alpha is nothing but the position, the cumulative function where it is landing. So I have put this value here, H3, that is 23.96%. So now if you see here, it's a decimal that we got it. So now I'm going to same thing, copy it here. I cannot copy because I didn't do the hard code here. C4. This is C. This is C4 is what here, right? That will be hard coded. C6 is hard coded. I can drag it here. So now here I have done the inverse of the binomial distribution at this particular level, and I'm trying to calculate. So here this false or 2. So here it is trying to take a particular probability and determining the number of successes that I'm going to get it here. So this is a decimals if I'm going to get it, because everything is because I have not represented function F9. Because I didn't put a recalculation. That's a function F9. So if you see here, I have put a number here and I'm getting the probability of success that I'm going to get it at various levels through an inverse function. Now the input of this probability that I put in here, this is a probability that I'm going to incur by here using the rand function. The moment I use the rand function, it is going to generate to me a number between 0 and 1. And that is exactly what I'm considering as my cumulative mass function. Because when I generate a number between 0 and 1, it could generate 99.9%, it could generate 1%. I don't have that control. And therefore, I'm saying that that's a cumulative mass function. I'm inputting this number, and then I'm using the same NP, and therefore I'm determining what is the probability. So if I see here, I quickly changing, for example, it's a random number, right? It's continuously changing. I don't know whether how many of you can see here. If I zoom this screen, can anyone see here now? Can anyone see here? I'm pressing F9. It's changing, right? Because that is because I'm generating a random number every time. That is, here I get a random number of 12%. So I'm going to do a binom dot inverse, go back to the number of trials, go back to the probability of success, use this particular number and generate to me the probability. Now, when I press F9, my probability changes. Now the probability cumulative mass function is 81.43%. That means I get only number of successes is true. I press again F9, I get 21.65%. I won't get any success. When I press again, 26.6% I get one success. I am determining the success using a random variable, because I don't know how many successes I will get. So when Asim Mankodi tried for an event, he has no clue how many successes he's going to make it. He only knows his historical understanding that he follows a binomial distribution of successes, and therefore he is trying to determine what is the probability. Once we know this, then it is simple to calculate whether there is a profitability of seminar is there or not. And once we know the profitability of seminar, in this case, when I got a value of, so now you might be wondering, I got 3 years, I got 1 year. Please understand, here I've used this random number, in this there's another random number. So the random number that got generated in column C9 is different from the random number in D9. So don't get confused on this. And this random number keeps changing. So this is the random number success I have. And Every time when the number of success is changing, a profit changes, a profitability value you can see here. Once I know this particular profitability, and I don't know this particular value 0 of successes has come in based on one random number. That is nothing but one input, which is a random input I have given. One times I have given random input. Now I am saying that I don't want to give one time random input. I want to do 10,000 times. I want to do 1,000 times because I don't know what will be the number. I just want to I don't want to use my gut feel. I want to see if I ask 10,000 people, what is their belief, the probability of success? I will have probability. And because I'm going to ask 10,000 people, I'm actually through computer, I'm asking 10,000 people. How do I do that? I'm actually plotted here 10,000 times. Each number is essentially asking different people. So in Excel, I'm sure most of you are very comfortable in Excel to fill in the number. It's easy. You put a one number here and series column, you get add number. And we are going, this is a data analysis. We are tricking this computer. So I'm going to delete this value here. I have put this particular formula linkages. This formula directly links to C9 into C3 by 2. And C9 is nothing but where the formula of random number is there. So technically, this formula links to that particular random number, and therefore now we can use the data table. In other words, it's a multiple what ifs. What I'm going to do is, I'm going to mark these two things. Go to data, go to what if analysis, go to data table. I'm going to trick this. I'm going to do a column input cell because we are going virtually down. So it's going to be a column input cell. And I'm going to pick up any other data empty cell. So here I just put some heading just so that we don't use it for any other purpose. This is an empty cell. I'm going to put this. There's no value there. It's just empty. Excel is thinking there's a value and it's going to iterate. When it did this, it is actually going to do, I did a calculation 10,000 times, and because Excel is going to take time now. So you saw this 10,000 times number, everyone? 10,000 times I have done it. Each time there was a random number that got generated. Each time based on the random number got generated, this formula called profitability got calculated. And each time, what is the profitability I got it? So the first person's probability distribution assumption gives me a 1,500 profit, whereas the fourth person's probability distribution assumption gives me a 3,000 loss. But these are all random. These are all 10,000 simulations I've done. Since I have done 10,000 times, then I can actually do the statistical analysis. This is the last step. Now that I've repeated this 10,000 times, I go there and look at the statistical thing. What is my mean? My average on this is 3,000 loss. And how many times I did sample? Count 10,000. So I'm going to do this every time, and this can keep changing. Now here, I did another F9. The random number got changed again. Again, the data changed. And I actually get what is the mean, what is the standard deviation, and what is the probability of the loss. How did I calculate probability of loss? I said, if my probability of making less than 0, I'm not even losing equal to 0, less than 0, I'm counting as a loss. And I said that given this particular probability success of 4% for a 35 tries, it's not worth doing it because I have a chance of loss of 43%. If I'm successful sometimes, I can make a maximum profit of 33,000. The maximum loss I'm going to make is 3,000. And the standard deviation is 5,300 under the binomial distribution. So now you need to take a call. When I say you, is the management takes a call. Okay, whether I will go ahead. I see that I have a 43% of making losses, but how much I'm going to make loss? I'm going to make loss of maximum of 3,000, but there's a 43% chance of making losses. Now you might say, what if I press again one more time random number? This changes. Every time when I press, this changes. So now I press, again the numbers have changed. So yes, it changes, but the probability of loss, if you see here, it tries to hover around 42, 42, 42. If you see the probability number, I don't know how many of you are able to see that number, that's hovering around 42%. So what happens is, if you do a sizable number of simulations, which is in this case, in this example, we did 10,000 times, it gives us a reasonable benchmark of the decision-making point of whether we should go ahead or not. So for a time being, I'm actually stopping the screen and asking you, anyone has any questions, anyone has any doubts till now? Because I'm going to repeat the same thing for different distributions and the different calculations. Anyone? Anyone did not understand? Anyone got stuck anywhere? Anyone has fundamental questions on what's the use of this then? It changes.
Yeah, hi, this is Rashmi. I wanted to ask, how do we determine alpha, as in what? So firstly, what is alpha? What does it signify? And which your input is to be taken as alpha in this computation? This is, yeah.
Yeah, Rashmi, that's a good question. Alpha is a random number.
Okay.
Alpha is a random number. Again, we understand, go back. I said it's a distribution function, right? Because we have not read the theory part of it. That's why probably you're struggling. What we are saying is, when we plot the data, we get a distribution. So let me again share the screen of the data so that, because that's why it's easier. So let's take this. Can you see this? Can you see the Excel again now for me?
Yeah, yes.
So if you see here, my particular distribution, it follows like this. I have a total 10,000 data points, correct? If you see the total 10,000 data points, in these 10,000 data points, I have 2,386 data points have a negative, it is between minus 3,000 to positive 1,500 data points.
Okay.
It is between minus 3,000 to 1,500. I have 23.86%. That is 2,386 records are there. Now, because it is discrete, it will find mostly in minus 3,000. So what is important for us to understand is, this is the distribution. How much out of 10,000? Okay, how do I say this? Let me put this number. Assuming there is a class of 50 students. Okay. Now, some people are of age group of less than 5, kindergarten. Some people are age group of less than 10. Some people are age group of less than 15. Remaining are more than 15, right? So what do we do? We classify. Less than 5, come in this, stand in this line. Between 5 and 10, stand in this line. 10 and 15, stand in this line. Greater than 15, stand in this line. That's what we do, right? That's a frequency. That's called a frequency. What you see here is a frequency. So here, I have classified this profitability that we got from minus 3,000 to 42,000.
Okay.
And I said, out of 10,000 records, 2,386 records come under this particular minus 3,000. 3,500 come under 1,500. 2,400. So I'm actually putting various buckets of students in various classes. That is nothing but you are distributing the data, distributing the people under various buckets, right? So this is exactly nothing but the probability distribution. So if you need to know the probability distribution as a concept for you to feel for it. Today, if you do not understand probability distribution, it's difficult for you to feel for it. This we have said it's a discrete distribution. I have classified minus 3,000, 1,500. I could easily classify. In a continuous distribution, you can't even classify. It's a continuous curve. I'm going to show you the curve also. Probably it's somewhere else. I don't know whether it's here. It's not here. It's in another shape. So give me a second. Give me a second. Yeah, OTP. 1 second. See, you should understand the probability. Alpha is nothing but the distribution, right? So here, this is the probability mass function. 23.86% is for minus 3,000. 35.02 is. So if I were to accumulate this, that is nothing but I'm going to accumulate this here, right? This is nothing but your alpha, what you're going to plot it. I'm not use F9. So if then right? So this is your alpha. So when I use the word alpha here, that's why if you have, and I told you in the beginning only, whatever function that I'm using your Excel simultaneously with me, it will be easier for you. So this alpha, what I was referring to, is nothing but the random number. So I don't know what is the alpha now. So I have asked people, tell me where you think it will fall. So I'll tell you how does it mean in practice. Let me help you in practice. I go and tell someone, boss, Ansim, how many success will be there? Asim will say it will be one success. For one success, I have a profit of 1500. Then someone will come to Rashmi. Rashmi, how many successes will be there? Rashmi say it will be 3 successes will be there. Then it will be profitability of 10,500. So like this, if you see here, according to this distribution, 2,386 people have said there will be no successes.
Okay.
That's why you have minus 3,000. 3,502 people have said there will be one success. That's why it's got 1,500. 2,453 people have said 6,000. So when I did a simulation of 10,000 times, it's actually asking 10,000 people.
Yeah.
I can ask 100,000 people, right? In politics, in exit polls, what they do, they ask sample, right? And that is exactly what we are doing here. Agree?
Okay. Yeah. Okay.
So now, once we know this, and thereafter we simulated it, we know where it is falling, which will help us taking the decision. The decision is, what is my probability of loss? What will be my probability of success? And that is where we're going to do it. So here, the input parameters are very important. That's why I said garbage in, garbage out. If your garbage in is probability is a wrong input you have given, obviously I'll have a garbage out. And therefore, you need to know. And how do we get to know this 4% success out of 35 tries? If you have done in the past. Have you done in the past? Yes. So what was the success for you? And that will determine this particular 4% probability for a number of trials.
Yeah.
Any question? Rashmi, clear now?
Yeah. Yes. Thank you.
Sure. Anyone else? Because I'm going to repeat the same thing. This is exactly what we are going to do. It's just that the functions are going to change. Silence. Okay. So I will not do a valuation one. I'll do a portfolio management, what I figured out from the website. And I'm going to show that here just to feel how we can use this various functions. So now here, I'm actually going to use a option pricing here, right? Last time, I think you have done, Asim has said option pricing has been done. So there are 2 methods are there. One where Black-Scholes was used, one is not a Black-Scholes, it's a simple 1+R. We'll see both. Everyone can see the screen for me? No. Can everyone see the screen for me? See, trust me, it becomes difficult when it's a tough subject to discuss if people are not responding. The 2 things can happen. Either you have not understood, because if you are not responding now, you'll not understand the next part also. I'm being very candid here, and I'll do my best to simplify it. And if you ask me again, I'll again try to simplify it again and again until I fail myself. And that's my number of success or failure for myself. So you need to help me in that. So how many of you are familiar with options? You are all familiar with option theory, right?
Yes.
Okay.
Yeah.
What's the call option?
Right to buy.
Right to buy. Okay. And what's the put option?
Right to sell.
Yeah. So it's both are correct. Only thing is you have to make it right to buy at a particular price.
Right.
Right to sell at a particular price. That's a strike price, right? Exercise price, not strike price. So here I'll see if I can use this to determine option and simulate that for our purpose. Now we are going to just play around with this. There's no rocket science here. And once you understand this basic comfort of simulation, then you're good to go. You can just practice it with various distributions. Let's start with this. My current stock price is 50. My strike price is 49.6. My exercise price is 49.6. Current stock price is 50. Is it at the money, in the money, out of the money?
At the money.
Almost at the money, right? slightly in the money, right? You can exercise at 49.6, you can sell at 50, but at the money, in the money, at the money, easy ways. Annual return. What is the annual return of this particular stock that you have received? That is something you can get it based on the historical data of the stock price movement, right? When you look
So
at
that is basically CAGR, right? That is basically stock CAGR.
the annual return.
Stock CAGR.
Absolutely, stock CAGR. So what I'm saying is last 1 year, how the stock price has moved. Okay. See, when you do in a 1 year, when you do a CAGR, it's essentially you're doing a daily compounding. If you're doing the ending price or the below beginning price, it could be a simple return also, because for 1 year it doesn't matter. When you compound it for more than 1 year, then it's going to be a challenge. Then it is annual volatility. You know, all of you know how to calculate annual volatility based on
No,
stock.
no. So that is where the issue is. So when you say volatility, which volatility should be taken? Implied volatility. See, there are 3-4 volatilities which are available, and certain volatilities are not even available freely, right?
Sorry, in certain volatility is not available, certain implied volatility. So you have used many terms. So let me understand further. Please go ahead.
Yeah. So what is the exact? So say period I'm valuing this particular thing, right? Then volatility might be high, but the overall volatility of stock, considering the previous trend, it might be low.
Okay, so go ahead. Volatility is for the period associated, right? If you are considering a period of a stock option calculation for 21 days or a 1 month.
Yeah.
So volatility that you are going to use it only for the 1 month volatility.
Okay.
You will never calculate. The problem is your question was interesting, so I was just hearing out to answer something else. But since I'll answer that also. The implied volatility that you are referred to, the theory behind this particular formula essentially goes to that whatever volatility historically that you have calculated, that should be applicable for the future for that particular underlying asset and the option. That's a presumption that we are making.
Okay.
So if the presumption is, suppose for example, let's take COVID time. There's a huge volatility at that time, right? Now, thereafter, if you're using that data for a coming forward call option projection, valuing call option, and you're using a volatility, that volatility may not be applicable for the coming period because we don't have that uncertainties of the COVID period at this point of time. So it is essential and important to realize the presumptions that are behind the formula. So we need to be careful what is the implied volatility. Suppose if you believe that this particular stock has gone significantly up and down and you are not able to use a volatility of this particular stock, but going forward you don't have that particular uncertainty, you could use a comparative stock and that stock's volatility as the volatility for this stock for calculating call option value for this stock. I hope you got it, right?
Yes.
So you should. So it's an important and interesting question for everyone. May I know your name, please? Sorry. Utsav.
My name is Utsav.
It's important. Remember one thing: when you are applying the formula, it's very important to know the underlying theme behind it. When you are applying this particular volatility, you are presuming that this volatility, what you have calculated, is applicable for the future, for the period that you are calculating for the future. Suppose if you are valuing the volatility for the next 3 years call option, that is a call option which is going to expire after 3 years, you are going to take the volatility that should prevail for 3 years. So one should know, and that should survive and sustain. And sorry.
Ganesh, where do we find this accurate data? So Money Controller, all those websites, or what is the source of such data that you use in this particular?
It's an actual stock price, NSE India. You don't independently pick up. You want me to show how to calculate volatility?
No, I don't want to know how we calculate the volatility, but I just want to know from where do we pick up this number of volatility?
The stock price. It's actually stock price. Through stock price we calculate. What is volatility? Volatility is nothing but standard deviation, right? Volatility is nothing
but say for example, if I say that I'm say we take an example of SBI, right?
Yeah.
SBI right now, if it is said, okay, so you have computed the whole thing, okay.
No, so we are all learning, right? So here calculation of volatility. I have taken the downloaded data from the money control NSC wherever. I put up the data for 1 year. Okay. Now we can. I've just taken the adjusted closing value, opening, high, low, close. I've taken the adjusted closes because if there are any dividends and all that stuff, it gets adjusted. There are two ways we can do it. One is the stock price movement follows a log normal distribution. Again, don't go into, I know most of you will be upset. Every other word I use a distribution. Sorry, in my lecture, it's a log normal distribution.
Yes,
So
sir.
what is the normal distribution has the values moving from minus infinity to plus infinity. Log normal moves from 0 because there is no negative. That's the reason why since stock price cannot be negative, therefore it's log normal. So we can calculate two ways. One is I can just do a log normal of today as of yesterday, and I can continuously calculate. This is the ln, not a log. Log is two ways. Now one is to the base 10. Log is to base 10. ln when you use the function, I don't know how many can see ln. ln as a function is nothing but it is to the base e. So we use the function ln here for the log normal. And if you don't want to use log normal also, you just have to do opening today's divided by yesterday's minus 1. If you see, they're almost the same. One is a 3.28%, one is a 3.34%. One is a minus 1.25%, one is a minus 1.26%. This is what we get as a change. Once we get this particular change, then we actually calculate nothing but using in Excel a standard deviation. So when you use the standard deviation of this value, you get the daily volatility.
Sir, can you press F2 on that daily volatility H2?
I have pressed it. You cannot see the value?
Yes. Okay. Standard deviation C5 to C. Okay. Yes, got it.
So once we have this, then it is a monthly or a yearly, because essentially you need to multiply by square root of 252 days. In this particular case, the number of trading days were only 248 actually. Basically, in a year, they say that the number of trading days is 252. So either you take 252, which is the standard, or you can take 248. So I did an annualized volatility. It's nothing but the daily volatility into square root of 252. That gives me my annualized volatility. So here we are not making any assumption. This is the actual. What I was telling when you asked me the implied volatility question. So the question was interesting for me because imagine because of a COVID or such events, these prices have been completely haywire.
Exactly, which is why I felt that implied volatility must be used. But then you gave the logic that you need to compute it for the period that you are testing. So if you are testing for the period when the volatility is higher, we might as well choose the actual volatility, because of which the option price will be higher. Else it will be much lower, and then we will always feel that this is undervalued, or this is overvalued option.
So the presumption is, therefore, one needs to understand the concept that whatever formula, the volatility which you are using in the calculation of the value of the option is nothing but that volatility has to survive during the period of the entire option. So we should know that. So if we know that is not going to be the true statement, then we need to look around for other solutions. The other solution is a comparable period where volatility is not high, or a comparable stock, other methods. You can actually do a reverse calculation. A comparable stock, calculate the implied volatility from a comparable stock, and that implied volatility apply it here. So what you do is you have the suppose the comparable stock is already trading at the call option value of some rupees. So you have a call option value, you have the stock price, you have the exercise price, you have the time period. Calculate the implied volatility there, reverse, and that volatility is the implied volatility which you apply it for your particular stock and do the calculation of the options. I hope.
Sir, will you be sharing this particular Excel sheet?
I will share everything, my dear. I have complete sharing.
Thank you, because I am able to get what you are telling right now, but I'll have to actually do the homework.
See, please understand, whatever I teach, everything is open, because end of the day, if more people are comfortable, more people are knowing things, better is for the ecosystem. All
So-
this is available for everyone.
So, sir, apart from this, so Reliance is listed, right? Now, say for this example, if we have a company which is a public company, but it is not a listed company, and say there is a requirement to value the option in that particular.
So give me a second. Sorry.
Sure. Sure.
Is it okay if I have my tea also while I'm speaking? Is that okay? Because
Sure, sir.
I hope you will not have any issues. Give me a second. Sorry about that. Sorry, Utsav. Sorry. Go ahead. Go
So,
ahead.
apologies everyone as well, but I have a few questions, hence I'm barging it over here right now. Yeah, so say there is a company which is, for which option price needs to be determined because there is a call option attached along with a particular deal that is happening, right? In that particular scenario, we do not have such variables like volatility or the stock price, because what valuation we have is the valuation as on date, which we would have done. We are not aware of what will be the exercise price. We will not be aware of the volatility of that particular company. In that particular scenario, how can we use this particular table to identify the actual value of this particular option? Say, so not only for the company, but say we are doing a straight bond valuation method, which is related to this optionally convertible debentures. There is also a price of the bond plus the option value. Now, how do we use this particular thing in the option calculation?
See, one of the ways is, this is even easier as compared to real options. One should understand, finally, when you have an optionally convertible debenture, let's take this example. Essentially, the option gives him there's a coupon that is getting a straight line debenture.
Yes.
And there's an option to convert into shares so that they get a better value.
Yep.
Right? So, is there a payoff? What is the payoff? Payoff is the actual value of the shares which is going to get minus what he is paying. There's a difference is the payoff.
Yes.
So we need to know that suppose if the face value of the coupon is 100 OCP. When he converts into shares, the value is 150.
Okay. So 15 rupees is the call price.
Not the call. Then you have to do the present value. It's not so simple.
Yes. So, but how do you determine at the inception, at the time?
Therefore, what happens is, again, Monte Carlo comes in there. So what you're saying is, today I have invested at OCPS, right?
Yes.
I have a right to convert, say, after 2 years.
Yes.
So therefore, you are paying a premium today after conversion, and the terms of the agreement will say that you will get at a particular conversion ratio.
Okay. So what you mean to say is that what you are paying right now, vis-a-vis what will be the converted, that value minus the value that you have paid today, and present value of that particular valuation gives you a roundabout option price.
Always. In other words, if you see K into e power minus RT is nothing but is the current stock price. Whatever is the final price, exercise price, into e power minus RT, if it's a continuously compounded, is nothing but, or if I were to do not it as a continuously compounded, but discretely, it is nothing but K divided by 1 plus R power T, is nothing but today's price.
So, okay. So basically you are trying to tell that it won't come out from the formula of the option pricing, but rather it will have to be worked out in the different way.
Yeah.
How you determine the call price,
if you try to apply directly, see, you can still apply. Eventually, we'll apply. We will see one of these things. What you should know is what you need to be able to derive if you are using a Black-Scholes, 5 things. What is my strike price? What is my exercise price? What is my today's strike price, spot price? What is my exercise price? What is my risk-free rate? Because entire Black-Scholes model or binomial model comes under the concept of a trading theory. Trading theory is that you are minimizing the risk, and that's the model of this particular option model. So you need a risk-free rate. You need the time period by when you need to take a call. And suppose if you say my OCPS, I can convert any time, then it's an American option, not even a European option. You cannot apply binomial. You cannot apply Black-Scholes, because Black-Scholes is for European option. Unless so, then you apply the binomial by actually trying to determine at various branches. Can I convert after 1 month? Can I convert after 2 months? Can I convert after 3 months? Now, each point of time, you need to determine the value of the company. When will I convert?
Yes, exactly. That is the another issue.
So that's a calculation. So what you do is, my company's growth rate is today right now. It is going to go at say 20% growth rate. That's the projections the management has given. So I know the company will grow at 20% at time period T. So I calculate the value of the company at time period T. I calculate the value of the time period T2. I calculate value of the company at time period T3. So I know that this is the value. Now, at time period T3, if that is the value, my particular investment, if it is giving me a better value of converting at time period T1, I will convert it. So that's my option. If it is not, I will not convert it. So it is a lot of exercise. See, pardon me, a lot of people, I know all of us are professionals, we charge to companies, right? Without realizing the complexity around the workings.
Exactly.
When you charge, therefore you charge, you think that this is a fees karke. But the problem is that is wrong. If you were to truly get to a number, so I'll give an example to you. I am right now valuing for a bank stressed asset portfolio. I'm valuing the bank. So bank wants to sell this particular portfolio to ARCs. Now, how do we determine what is the value? The only thing that is there with the company, all the portfolio has no assets except for the collateral. Collateral are largely real estate. So they said these are the real estate properties value. If this is the scenario, what is the uncertainty here? The uncertainty is the time period for someone to get a court order to take the possession, time period it takes to do an auction and realize the money.
Liquidation is the main issue. Yeah.
That's a liquidation, the time period to auction, right? Which is auction and liquidation. So what happens is you actually estimate this particular uncertainty of time period. And then you say the probability. So what I said is, okay, based on various people, they said, sir, it can take 18 months, it can take 36 months, it can take 54 months. How do we say that? So then you try to classify various criteria. If there is a physical possession and no dispute, this thing, it will take 18 months, lowest, highest is 36. If there is a physical possession not there, symbolic is there, and you have to still get a court order and then do it, it will take say 36 months to 48 months. You start plotting it. Then you will ask me, why did I take 18 to 36 months or 38 to 40, 54 months? Here I said, it can happen anytime. It's a continuous distribution for me. It can happen in 18 months or 19 months or 20th month or 36th month, because that's the experience of number of auctions. The probability is uniform at that point of time. Then what you do is, you don't know which one to take between 18 to 36. You run a Monte Carlo simulation. You say that, I don't know. I know the probability that this is going to be between this equal probability between 18 and 36. Let me do a 10,000 simulation. Whatever I get it, that becomes a useful input for me for my calculation. In other words, I have asked 10,000 people. I asked everyone, what is your number? They said, give me a number. I got a number. Based on this, I'm putting a number. Which income tax, which authority will question the method? So the objective of valuation is essentially to understand the implicit presumptions that have gone behind a formula before one applies a formula. And that's the serious stake for every professional. All of you are highly educated, and it's important to really do that before you apply anything. So any questions further on this? Anyone else? Should I continue?
Yes, sir.
So volatile. So here I just gave option pricing. Here I took it as a. Can you see my screen? No, not yet. No?
No, not yet.
Can you see my screen?
So Ganesh ji, so if we say so this is a future data, right? If I take the data backwards, will it throw the same results which would? So is that a way how you backtest this particular model?
You need to ask me again. Sorry, I missed out. Sorry.
So say this data is from say we are sitting on say 17th February, right? No, I think.
I just pulled up the data.
So can we so this is for future, but if I take say historical values to determine the historical option prices, will it throw the same results or they would differ? If you would have backtested,
in my view, they would differ
they
because
would differ.
it will not be exact in my view, because at the end of the day, most of these particular constructs of the modeling are with assumptions. For example, Black-Scholes formula, if you have applied, it is with no dividends, it is no transaction cost, all those things.
Yes.
Reality will be not be there like that, right?
Plus human emotions.
Yeah. So basically, what it says is that these models give us a direction, and it will not be too far away from a principal perspective.
Okay. Okay.
Agreed.
Got it. Got it.
So
Thank you, sir. Thank you very much.
yeah, Viraj has asked me, the land parcels would you still provide for a discount for lack of marketability, or has the probability captured that? See, land parcels valuations, valuer would have done it. As far as I am concerned, the lack of marketability and liquidity is something I am measuring in terms of time frame. So once I know the time frame change, that will take care of my valuation. Yeah. So here, I was going through the Black-Scholes option pricing model. I have got the strike price, spot price, exercise price, volatility, time period. So I have calculated the return for the time period and the volatility for the time period. And then again I did Monte Carlo simulation. So here I have used the normal distribution. So again, let me help you with the normal distribution now. Is everyone following me? Again, in Excel, there is norm.dist. Now, how many of you are familiar with normal distribution? What are the main parameters for normal distribution? I think people are silent again. Okay. See, normal distribution has a mean and a sigma, right? If you have a mean and a sigma is the standard deviation and the mean is there, then your normal distribution will be there. So for example, here, I apply 1. In this case, this is my norm distribution. My average price, average return is 10%. I'm expecting at 9% what is my confidence level. My average expected return was annual was 10%. The standard deviation was 20%, and I'm expecting a cumulative distribution. It came to me 48%. So here, please understand, if I put here 10%, I get 50% because that is the mean. So 50% is exactly the middle in a bell curve, right? So when I say that at what is at the 50th percentage, give me my annual return 10% will be there. So my input was 10%. So if I ask me what will be my probability distribution cumulative one when my return was only 1%, it is 32.64%. So I don't know if you can visualize a bell curve. When I draw a bell curve at a particular point where my return is only 1%, my probability of 32.64% means there is a data available less than or equal to 32.64%. So the below 1% also I have 32.64% of data available. This is what it means. Below 1%, I have 32.64%. When I say at 10%, it says at 50%. So up to 50%, I have data of returns of 10%. Once I know this, I have a norm inverse function. Just like we had a binomial inverse function, here we have a normal inverse function. Again, it has asked me to input the probability. How will I input the probability distribution function? By using a rand number. Rand number gives me a probability between 0 and 1. Again, what is the mean? I am telling that it's a normal distribution. Normal distribution requires two input parameters. One is a mean and one is a standard deviation. So one is a mean is this, and one is a standard deviation. I get a particular value. You need to give me a minute, please. How many of you have understood or not understood? One of this has to satisfy, right? The normal inverse and normal distribution. Anyone understood? How will I know whether you have understood or not understood? Is there any solution I have? So here, given this particular data with an assumption of normal distribution, I have calculated what will be my return for 1,000 simulations. So I have given this particular input. What does this tell me? It is telling me that I am going to get a minus 0.19%. My volatility, my return was 2.24% for this particular 0.23 years. Because return 10% was for full year, I have calculated the return only for this particular period, which is 0.23 years. How did I get it? Current date was 20th Jan, maturity date was 15th April. I have calculated the time period, and that is nothing but in years 0.23. So my 10% became 2.24%. And volatility also I have calculated according to the time period of 0.23 years. Now, given this particular thing, I have calculated for this particular time period what could be my return by simulating. When I simulated through a normal random distribution, for first time I got minus 0.19% return. Third time I got 12.93%. I got various numbers. If I were to plot this data, can you see this graph? Is this a normal distribution? So what happens is, when I plotted this data, this is because I have actually derived this data using a normal distribution function. Once I know this, but this is a return I have it, I know is nothing but what will be my price. My price is nothing but my opening price, strike price into this particular thing will be my actual stock price, and the payoff will be this minus my exercise price. I think this should be B1. Okay, when I give the Excel file, if there is any formula error, I am sure you'll be able to figure it out. See, what does this say here? My price would be 49.97 here. In the first scenario, my exercise price is 49.6. Therefore, if I have the exercise price 49.6, I can sell at 49.97. My payoff is 0.38. My put payoff will be 0. If I had a long put, it will be 0, obviously. In the second scenario, the price captured was 43.83, whereas the exercise price is 49.6. So what happens is, why would I exercise at 49.6? I would rather have a 43.83. Therefore, it is a 5.76. So this is actually the way you calculate for 1,000 simulations. The average of this could be a long call and a long put. Any questions? Any questions? Understood how to look at options?
I have just one question here.
Please.
The volatility which you have calculated for the time period, which is the balance time period, what happens if the maturity date was after 2 years or something? In that case, how will you have extrapolated this volatility? So you're on mute.
Can you hear me now?
Yeah.
Volatility for a time period T is nothing but annual volatility into square root of time period. Suppose if you have calculated annual volatility and you want to calculate for a call option for 3 years, you use this particular function of annual volatility into square root of the time period. So let me do this number for you. Can you see this here? What I changed?
Yeah.
I changed the expiry date. So the time period has changed. Volatility. See, it's a simple way to look at it. Standard deviation is always measured in absolute term. It is not a ratio, right? It's not a coefficient of variation, right? What is absolute? Suppose today's stock price is 100. 1 year down the line, results come in, it performed well, the stock price moves to 120. Again, second year happened, again stock performed well, the stock moves from 120 to 135. Again, the performance went, third year, 135, it went to 150. So if you were to look at it, stock moved from 100 to 150 over a 3-year period, probably around say 15% return. But for a standard deviation, it is an absolute 150 and an absolute 100. It will take the average between 100 to 150, the stock movement, and it will do the formula of sigma xi minus x bar whole square divided by n minus 1 square root. I hope any one of you is familiar with the formula of standard deviation. What I said? Standard deviation is I calculate the mean of the data. I have all the data dispersed around the mean. I take the distance between my point and the mean and I square it. So some could be lower, some could be higher. That's why I square it. So all numbers will be positive. I add up all these numbers. And when I'm doing a sample standard deviation, I divide by n minus 1. If it's a population, I divide by n. I get a value. I take a square root of it. That becomes my standard deviation. So automatically 3-year volatility will be higher than a 1-year volatility, which will be even lesser if it is a 0.25 or 3-month volatility. Agreed? Any questions? Was it fast, slow, comfortable, not comfortable, complex, easy?
Sir, I have a question.
Sorry?
Yeah, I had a question. When you are determining the volatility, should you consider standard? So that while determining that formula, I saw standard deviation dot S. Should you
Yeah.
consider sample or population?
I always prefer sample because at the end of the day, it's not a population. So I prefer, because the difference between a sample and a population is the division by n minus 1 or n. Most of our data, we are working on sample data, so it should be n minus 1. There's a rationale behind it. It is actually, the theory goes, I'm not getting the theory much. It's a degrees of freedom. So when you take a sample, you are restricting the first point and the end point. Because you are restricting the first point and the end point, by saying that I need 100 number, therefore your degrees of freedom is lesser by 1 number. That's why you say n minus 1. Whereas in a population, you are not restricting and therefore the degrees of freedom is n. since all of our data when we work is sample data, it will be n minus 1.
But sir, is there any study which says that it is better to take sample and not a population?
No, it's not about studying better. No. If your model is used working on sample data, you will always take sample standard deviation. You are not working on population data. See, again, the theory is simple. Suppose if I were considering the entire population data for some reason, some calculations, then I would definitely use the population value. See, just now what I explained, when you take the, essentially what we are saying is, when I take a sample population, sample data, I am restricting the nth value. Okay, how will I explain? If I can help, I'll think through. Okay, suppose if I take a sample of a class, not the entire school, one class sample, I want to extrapolate to the entire school, right? Now, what happens is, because I'm taking the sample data, my mean is there. My mean is getting restricting the last sample nth value, because my mean has to be satisfying to the n. I do not have the flexibility for the last value for the mean, because it's a sample. So I lost 1 degree of freedom. Because I lost degrees of freedom, I divide by n minus 1. And that's, we don't need to get into mathematics part of it. Conceptually, most of the times in our world, you'll be working with sample data. So you should take a sample, if that helps.
Okay, thank you.
Any other questions? So what I understand is, I have tons of other stuff, and it's 2 hours, and I just did 2 parts of it. The concept is the same. So what I will do is directly I'll take you to the big Excel file, indicate to you and help you, because there's one more distribution which is important for us to know, which is the triangular distribution. Okay, before I go to the last one where I'm going to open that Excel file, because that file is, because of so much of simulations I have done, it slows down. So I thought I did many small files, but it's already 6 o'clock. I'll open that particular file to explore the free cash flow part of it. Any questions till now on the way I applied Monte Carlo? I think you should answer. No? Two things happen. If you're not answering, either you have not understood or it's not interesting.
No, sir. Actually, we have understood.
That's
so
nice.
How the simulation has been applied.
That's nice of you, my dear. So, and my duty is to continue. So what I did is right now, I have not opened many other Excel files. I'm opening the big Excel file. I have applied various simulations for various distributions, for various factors, just for the purpose of example. Don't ask me, is it really true this distribution is applicable for this? I don't know. Largely, I tried to do. Let's see one particular P&L here. The P&L here is, I have a sales number 2 crores. I have a gross margin. I have a gross profit, sales, general and administrative expenses, EBITDA, depreciation, amortization, EBIT, PAT. I got it, right? Then I have NPM. All of us are familiar. We're all finance students. For us, it's back of the envelope, right? All this. Now, so I did a free cash flow also. And I took certain ratios also. Debt to capital expenditure, etc. Then I have a cost of equity. I have a WACC. I have a terminal value to sales multiple. Agreed? I have put certain ratios here. Balance sheet I put up here, and I said, what is the sales growth target I expecting, gross margin expecting, so on and so forth. Let me get a glass of water. Just bear with me. Yeah. Okay. So now here, so this is my stats of day 0. All of us are familiar with this data. Sales, all these numbers, we are comfortable. Now I started assuming certain distributions for each of this. The clients of mine has comfortably says, my sales are going to go. Volume will be in a triangular distribution. What is triangular distribution? Triangular distribution says, okay, my worst case, I'll grow at 15% sales. My best case is 20%. My most likely case is a 17%. All of us are familiar. This is what we get every time from the clients. So we get a whenever we get a 3 scenario like this, it is nothing but we are actually saying that most likely, worst case, best case. So it's a triangle now. 15 and 20 is the lowest and the highest value. Most likely is somewhere in the middle, and therefore it forms a triangle. And this triangular distribution, whenever it takes, we apply the triangular distribution method of generating the data for the distribution. Then we have something called a discrete non-uniform. When I say discrete non-uniform, sale price, I say my product can be 100 rupees per piece, 101 rupees, 102 rupees, 103 rupees. Each is a discrete value. It is not continuous between 100 to 103, 103.234, 104.123. No, it is completely a discrete specific number, 100, 101, 92, 103, so on and so forth. Discrete non-uniform. Non-uniform, when I'm saying my 100 rupee sales price, the probability is a 30%. My 101 rupees, the probability is a 5%. My 102 is probability is a 15%. So when I have a variation of discrete, it is not even uniform. So a discrete non-uniform distribution. Gross margin. Gross margin, I said, it's a normal distribution. So when I say normal distribution, it follows a bell curve. Then I have a sales, general, and administrative expenses. It has a uniform continuous distribution. What does it say? If my sales and general administrative expenses is 8%, it can range between 8% to 10% anywhere. Why? Because it's a ratio. A ratio can take a specific decimal level till the 10th decimal also, depending upon where I reach the sale, because some part of my costs are fixed cost. Therefore, it is a uniform continuous distribution. That means the probability of it being 8% is equal to the probability of it being 8.1%, equal to the probability of it being 9%, equal to the probability of it being 9.745%, equal to the probability of it being 10%. That's when we say it's a uniform continuous distribution. I don't know where it will be. It will be between 8 and 10. Then I said sales to operating capital assets. This is for reinvestment purpose. Here, I said it's a uniform but discrete. Here, what I said is it is uniform, but it's a ratio, right? I said that this ratio will be between 3 or a 4 or a 5 or a 6. However, it is equal probability of, say, one is 19.8, one is 20.2. They're just close by, but it is uniform by nature. But it's discrete, specific value. So I have captured all this for us to continue. Now, please ask me if you have questions here. I'm going through it will be difficult otherwise. The first one is my data point, sales value. Whenever you're doing the valuation for your client, start plotting data like this. There's a minimum estimate, there's a maximum estimate, there's a most likely estimate, and there's a year 1, year 2, year 3, year 4, year 5. So what I did is I projected for 5 years. I can have a different. So in this example, I have taken is the same percentage year on year. this can be completely different. It need not be the same, because year 1 and year 2, you have a low base, you can grow at a higher rate, but year 3, year 4, year 5, your base has increased, your growth rates can be small. But for example purpose, I just put same. You can always have minimum, maximum, most likely. For the sale price, because it is discrete and non-uniform, my probabilities are different. If you see here, for it will be 100 rupees for 115%. For 101 rupees, the probability is 30%, so on and so forth. I just put a number each year, what will be the price. But the probability is the same for each year, is what I understood. Because this is same, the price is varying. Gross margin to sales. Here, you remember, it's a normal distribution. Normal distribution requires only two parameters. One is the mean, one is the standard deviation. So my average gross margin is 20%. My standard deviation is 2%. What does this mean? It could be 1 sigma is 20 minus 2 and 20 plus 2. That is, my data with 66% confidence is between 18 and 22. If it is 2 sigma, that is 20 minus 4, 16, 20 plus 4, 24. So between 16% and 24, I have a 95% data. And 3 sigma is 20 minus 6, 14, 20 plus 6, 26. Between 14 and 26, I have 99.9% data as far as the gross margin is concerned. SGA percentage to sales. This I said it's a uniform continuous distribution between 8 and 10. The lower value I defined, higher value I defined. I said it can be anywhere between these two. I repeat, for each of the years, the data can vary. Now, delta, this is the sales to operating assets. I said it's a discrete distribution. Either it will be 3%, 3.54, 4.55. However, it's a uniform function because my probability of each of these is very close. Therefore, I said it's discrete but uniform. My working capital to sales ratio, I said again, it's a uniform continuous distribution between 5 to 6 because sales is a ratio. It can change and decimal numbers can come out. That's why I say it's a uniform continuous. My interest rate that I am going to borrow, I put a triangular distribution. I said the lowest cost I'll get is 11%. Most likely I can borrow at 12%. Highest that I'll be paying is 15%. So I defined a triangular distribution for interest rate. Contingent liability, I just said it's a 50% probability it can happen. But whenever it happens, I have an impact of 1 lakh loss. And I said, because there's an interest that gets charged by the department or any liability, I just added up 12% as the interest cost that gets added up. So the first year it doesn't happen. Next year, liability will increase to 1.12, thereafter, so on and so forth. This is just, I have assumed. Now, from now onwards, I'm going to actually apply the triangular distribution, each of the distributions, and show it here. First thing is for a sales volume. So we calculate something called as a C variable. This is a checkpoint variable. This is nothing but, if you were to see the formula, it is 74 minus 72 by 73 minus 72. You see here, 74 is my most likely, 72 is my minimum, maximum is in the middle, 73. So I'm dividing the ratio by the maximum minus minimum. If you see the formula here, 73 minus 72, that is the maximum. So I'm saying that what 74 minus 72 is the most likely minus the minimum divided by the maximum minus minimum. I'm calling that as the C variable, cutoff variable. It's basically, mathematically, you can prove it as a point, but I just use that simplified formula here. Now here, this is the way I actually calculate the sales growth rate after generating a random number. If you see here, I've just generated a random number. This is a rand function. I just derived a random number. Now what I'm saying is, if my particular random number, what is this random number? This is a cumulative density function in my entire distribution. So here it is shown as 9.67%. The second one, it is showing as 94.67%. So what it is saying is, if this particular random variable, if I'm going to plot a triangle, it starts between 0 and 100. Triangle has a value between 0 and 100%, right? Because it has a lower value and upper value, means that's a cutoff point. So when I say 9.68% value, it is trying to give me at 9.68% value is my data. My data is lying at 9.68%. If my data is lying at 9.68%, what is the corresponding sales growth rate is what is my estimate is. If my data is showing in my triangle, I'm at 94.68%, my corresponding sales point, if I were to draw, I don't know whether you can, how do I just do this? I don't know how do I draw. Suppose anyone insert, I got a triangle here. Yeah. If you can see the triangle here, right? This bottom, if you can see here, this bottom is A, this bottom is B, this bottom is C. So now this is an equilateral triangle. The triangle could be any shape. It could be completely skewed also. That doesn't matter. So what happens is, this is your most likely. This is your maximum. Can you follow me? And this is your minimum. So what happens is, when I am generating a number, so this is a 0. This is your 100. So when I say 100, it means is the area. So if I were to draw a line, if you can, if it helps here. Anyone is following this or no one is following? Line. Can you see this line? This line says the area below, between this small triangle now at the line, that area is 9.68%. Suppose if I were to draw this line here, what it means is, this entire area from A, C, D, E, if this entire area is 94.68%. That is how we say this is the. So now at this particular 94.68% area, what is my sales growth is what is my sales estimate. This is how you actually do in this particular calculation of sales estimate. So this is the formula that you use it. This formula is a simple mathematical formula which you apply it, and it's a very simple one also if you derive it. And you can actually see, depending upon your random variable, which is nothing but telling where is that straight line. Sorry, someone has raised this line. Oh, it's my own this thing. If this particular random variable is telling me, give me that cutoff point at that point of time, what's my sales growth? That is how I estimate the sales estimate through a triangular distribution. Anyone has any questions of this? We have already learned binomial distribution using the binom function. We have already learned normal distribution, Excel as normal distribution. In triangular distribution, we don't have direct Excel function. We need to input this particular formula, which will give us the value. Unless some private people who have developed the add-ins, you have to download that add-in. You can use it. Otherwise, you can just apply the formula. No questions still? Everyone is clear? Fair point. Now, sale, we have seen sale volume. Now we will do sale price. Sale price, we said 100, 101, 102, 103, 104 is a discrete distribution, right? Because it's a discrete distribution, we have actually calculated. This is I have generated a random value. What does this say that? I have used a lookup function. What does lookup function do? I go back to the data again. Kindly see this data. My probability is 15%, 100 rupees per sale. What does it tell? Up to 15%, the probability of the sale price is 100 rupees. That's what it means. The probability of sale price being 101 is greater than 15% and less than 30%. That's why it is 15 to 15 to 30 is 101. Again, it is between 101 and 102. The probability is 30 to 55%. Because so this is 15, so it became 45, it became 70. So you need to see a distribution which is adding the probability. So what I did, it started with 0. First cutoff point was 15%. Next cutoff point was 30%. So 15 plus 30 is 45. Next cutoff point was 25%. So 45 plus 25 is 70%. Next cutoff point is 20%. So 70 plus 20 is 90. What does this tell you? What it says is any probability between 0 and 15, the price is 100. Any probability between 15 and 45, it is 101. Any probability between 45 and 70, it is 102. Any probability between 70 and 90, it is 103. And greater than 90, it is 104. Now that I know that this is the data distribution, I have used a lookup function where I have given an input of a random variable. When I gave an input of a random variable, it gave me a number, say, for example, in this case, it gave me 103. So what I will do is, I'll just do a rand value here. What is the value I got? I got 70.83, right? Because I got 70.83, it is more than 70 and less than 90, the value will be 103. So I'll just do a lookup function. Instead of having rand here, I'll just refer to this particular cell. So if you see here, the value keeps changing when I keep my random number generating. Right now I click the F9 button. So now here, if you see here, it changed to 54.4. 54.4 lies between 45 and 70. Therefore, the corresponding sale price is 102. When you're doing a business planning, when the price is not certain, you can actually do in this particular probabilistic function to determine what is the likely estimate of the sale price. Should I continue? This is how you do it for discrete. Asim, are we good to go?
Yes, please continue.
Sure, right? Now it is a gross margin to sale. Now, if you see here, gross margin to sale, I said it's a normal distribution. Remember, we have already learned in the option pricing, normal distribution, we just use the function norm inverse. And when you use the norm inverse function, the input parameters we require is a probabilistic distribution function, which is nothing but random number. And you read a mean and a sigma. The mean and a sigma has been given above for a gross margin to sale. The mean is 20%, sigma is 2%. Input the data, you get what is the gross margin to sale as particular estimate. Remember one thing. Remember the slide that I have shown to you, input parameters. Now I have so many input parameters. Each one, when there's uncertainty, I generated a random sample by putting a number. Each one gave me an input number. If you were to do a what if analysis, it will be a nightmare because you need how many you have to do. So here, simulation, Monte Carlo helps in this because you are in a position to take so many comfortably. Next is sales, selling and administrative expenses. Now here, if you see here, this is the uniform continuous distribution. As I said earlier, between 8 to 10%, the value could be anything. So whenever you have like that, it's a simple formula. You take the lowest value because it cannot go below lowest plus you generate a random number, which will give you a probability, and that you multiply by the highest minus lowest. Because what you're saying is, if my random number generates 1, for example, it will the outcome will be the highest value. If the random number generates 0, the outcome will be the lowest value because that is the bound, right? It is between the lower value and high value. That's why you use a function lower value plus the random number, which is nothing but the probabilistic distribution function, which is a cumulative function, and then multiplied with the difference between the high and the low. Like that, you estimate the value for SGA. Now, all others are same. Interest rate was a triangular function. So that's how. And for contingent liability, what I did, I generated a random number. I said the liability can be 50%. Either I'll have liability or I'll have no liability. I said, okay, I generated a random number and I checked whether it is more than 50%. If it is 50%, I said liability occurs that time. If it is not 50%, liability will not occur. That is how I have actually calculated this sheet. If you have seen here, each of these input parameters, I've actually calculated, I've done one random sampling. For each of these, I've done one random sampling for 1 year. For each year, I've done like that. Now that I have done one time like this, now what does Monte Carlo say? Monte Carlo says, why don't you do 10,000 times? Monte Carlo says, can you do 10,000 times? Can you do 100,000 times? It depends on your Excel power, right? Machine power, right? What it is saying is, I have done one time random sample. It is asking one person. I know the boundary, I know the distribution. So can I take data within the distribution 10,000 times? Now, when I do this, I have a sales here. I have the minimum, maximum, most likely we have taken from there for each year. So for each year, from there, I have actually pulled up the data and put it here. I didn't do there. I've already calculated random sample. I put it here. Once I put it here, I used the data analysis table, which I've shown you earlier how to use it. When I did the data analysis table, actually I get a plot of the estimated sale value for year 1, year 2, year 3, year 4, year 5. Are you with me? And once we know, and remember one thing here, so that we cannot make a mistake here. So that we know that is taken care. Simulation. I have multiplied fax C41 into 1 plus fax D107. 41 into 107 is nothing but sale price into sale quantity. If I see 41 into 107, this is my 107. My 107 is what? Sale volume, right? And then your fax C41, I go back here, I pick up. That's the first time. My base value. Because what I have is a growth rate there. This is my quantity. My quantity will grow by this much number. The opening quantity into the growth rate I have estimated, I get the growth quantity, sale volume. The second time what I did, I have taken the opening balance, the previous year's number that I have generated, that into the estimated growth rate in the next year. Because the growth rate is always over the previous year, right? So to that extent, I have taken care of the previous year requirement. And once we have that, this is the sale quantity that we get it. And if I were to plot this particular data for any year, it will follow a normal distribution. It's a triangular distribution. Triangular distribution approximate to normal distribution when you actually increase the most likely value with a high chance. Similarly, the discrete distribution. I have estimated using discrete distribution what is the value in D115 for sale price. Once I have estimated that, I have simulated it over 10,000 times. So now, like that, whatever value I got it there, I put it here. I simulated sale price, gross margin for each year, for all the 5 years, for each parameter, whatever I have done an estimate. In practice, you don't need to do for all if you feel all are not sensitive. Whatever is relevant and important, you can do for that. Now, what is revenue? Revenue is nothing but sale quantity into sale price. So I calculated revenue for each year, calculated gross profit for each year because I've estimated the margin. I have the sales, therefore I have the margin, right? Now, the margin percentage was in the column. I have the sales here because I have got the revenue calculation. So I multiplied with this, I got the gross profit. Then I have a SGA expenses. This is also as a percentage to sales. I have estimated the SGA percentage to sales from the simulation each time, and that I multiplied by the revenue here to get the in lakhs. Similarly, EBITDA, depreciation, interest, EBT, I just calculated based on that, and therefore the tax. Here I apply the tax straight based on the tax rate that we have calculated, and therefore profit after tax and capital expenditure. Because I have calculated the sales upon operating capital assets, based on that we have simulated for capital expenditure also. And sales upon working capital, we have got a ratio for the target. Now we have the sales, therefore we have the ratio, so we can calculate the requirement of working capital. Based on the working capital, we can calculate the change in working capital and also the debt component that we have. We have the opening balance bank, and we have the debt. We have the ratio or debt upon assets. Based on that, we have used formula to calculate debt upon assets. Because we know how much we have interest paid, right? Reverse calculation, we can actually calculate how much is the debt. Contingent liability, I applied a formula. If a random number has generated any time, wherein it had picked up one particular year. So, for example, it had said that in year one, the random number said you'll have the liability. So I have put a condition, assuming that if there's a liability has happened in year one, I will not have that liability again here. Even though in my estimate, it will show it throughout all the time. In actual incurring, I will not incur it here because I know that I have already incurred. I have adjusted the calculations for contingent liability, and therefore I calculated the free cash flow. And terminal value in this example, I have taken sales upon sales multiple as the terminal value. I have the sales, therefore I could easily do the multiplication to get the terminal value. And WACC, I have the debt, I have the equity, I have calculated the WACC. Present value of the cash flows, present value of the terminal value, and therefore I have the enterprise value. And I have the debt, therefore I have the equity value. Anyone has any questions till now?
Sir, the WACC that we are considering, is it a rolling WACC or is in how?
See, each time I have calculated interest. Based on that, I have calculated what is the likely debt corresponding to that interest. Debt. What is the corresponding debt? And based on the corresponding debt, corresponding equity, I calculated the WACC.
Okay. Okay, so the capital structure is derived based on the interest that is being.
Yeah.
Okay.
So therefore, now in reality, between you and me, if you were to read Ed Bodmer, the toughest thing is to calculate WACC than anything else. So that's a different session altogether. But nevertheless, for the time being, that's not our session today. It's a simplified version. So I have rearranged this entire data of the free cash flow and the present value of EV in an orderly fashion. So lowest to the highest. I have done using a small function, ordered. Why do you think I did it? Because if I were to look at the data, again, the way to look at it is if I were to draw a graph here. I don't have a graph here, so let me do the graph. Suppose if I were to take this thing and I plot chart. Can you see this chart? Here, this is a normal distribution, right? So when I arrange like this, it helps me to tell me this is the lowest point, this is the highest point, this is the area. That's why I arrange this in the entire small to lowest to highest. You don't need to do that. You can use directly a percentile function also. So anyways, here, if I were to, one second. So if I were to cut this and take it to here, so I can explain it here. Okay, now here. So if I take the conclusions, in my year 1, the maximum value is this, year 2 is this, year 5 is this, NPV is this. The minimum is this, the mean is this, the median 90% confidence. What we are saying is, in this graph, if we were to see here, my 90% is somewhere here. If I can draw a line, I don't know how to draw a line here. It doesn't come here. My cursor is here, right? So I'll just put a highlight here. If you can see here, this is the cutoff. So the lower side, then my cursor is there. This will be my 90%, the end will be 100%. So this entire area is my 90% confidence. When I say 10% confidence, if I want to, this is my 10% confidence here. The data is falling here. So this is what it means. How much is my confidence at 10%? How much is my confidence at 90%? So when I said that in a Monte Carlo simulation, sometimes you're not giving the exact data, you are giving a range to them. With 95%, 90% confidence, I can say my NPV would be 326. That's a big confidence level, right? And my mean is 308. I can say with confidence, average value. So when you're taking, suppose if you are doing this particular valuation here, and you have this absolute value, sales growth 15% le liya, volume itna le liya, you have taken a static some numbers and you did some calculations and you said this is my output. How do you know it's right? How confident are you that you are with these numbers? What we do, we take a management representative. Management ne bol diya, humne le liya. It itself, valuer is supposed to do his interpretation, right? You are supposed to know the industry data. Industry gives us a range, right? The industry is likely to grow between 20 to 25%. So we have a range, right? So here, when we are doing a valuation, we can actually calculate a range. And once we know the range, we can actually give a perspective to the valuation saying that this is a lower value, this is the higher value with this confidence level. Therefore, this is the median, and therefore the business call where it can take. And if someone were to say, put your mouth where you want to stick yourself, you can say, okay, listen, I'm comfortable at 75% confidence level. Let me take the value of 75% as my basis, or a 50% basis. And that is how you determine the value of a company. Till date, what we do on a static method. We identify some numbers with some growth rates, depending upon what customer wants, and put it. I'm not saying that, I'm not even getting in there. And what I'm saying here is, once you know before what customer wants in, try to look at this data and see where you are falling and see how much far away you are from where the customer is expecting. And then you can question customer, say, this is what is the data showing. Sales volume is this. No, sales volume, because he doesn't know what number you are taking. You are asking him the range, right? So he's happily giving it because he has not seen the impact of all these things. He's giving you the range. Then you will say, this is your data and this is the number. Unless your expectations. So now I'll come to the business side. This is all the valuation side. The business side is, okay, if my sales volume is this, if my marketing cost is this, my present value is this. Imagine if I do a marketing spend higher, which is nothing but SGA and expenses, I increase it higher in the because I'm going to spend more, so I can say that I'll spend more. Where will my NPV again? This entire thing gets recalculated, right? So now what happens is, the difference between the NPV for a given confidence level, for a 90% confidence level, when my SGA was around 20% with a standard deviation of 2%, and when my SGA is around, not SGA, SGA was around 8 to 10%, when my SGA is 8 to 12%, what is my NPV at 90%? The difference in the value, I'm repeating it again, the difference in the value is the additional value that you are generating. Because you're spending more, you're generating, right? So how much spend you are worrying about, you know the number. Because you are increasing the percentage of the value, you know the number. how much NPV you are getting, you will know the value by simulation. And then you can do a business decision. Is it worth it? If I'm spending this much incremental marketing expense, how much additional NPV I'm getting it from an entire simulation? That is the business understanding. And it has far more implications when you take decisions for the business. And unless you are certain about what kind of a distributions, what kind of a data pattern it will follow, reasonably in finance, it's a triangular or normal distribution, you are safe. And rather, the distribution that I referred to, you are good to go. But once we know that, you can take so many business decisions for a client, which is giving you with complete confidence. You can say that you have 25% confidence level of achieving this. Would you want to go ahead with spending this much money in marketing expense? If you're suggesting an M&A acquisition to any customer, you can actually tell them that this is your median NPV, which is the price that you could do it. You're spending more, then that's the additional money that you're pumping in. Unless your assumptions change. And the assumptions are a function of the data. Someone can say that, well, I can grow at whatever rate. Say, yeah, please show me historical data, show me the pattern. And that is how you're going to use this. So in simple terms, Monte Carlo simulation is not any rocket science. Monte Carlo simulation is what it is doing is, instead of we going to each other, talking to each other, and asking what is the input and putting in, it is a computer generated simulated number. That's all from my side. Any questions?
Hi everyone, do we have any questions for Ganesh ji?
So, sir, one general question on this is we were referring to the mean and max in the output. Okay. So can we interpret that, let's say the minimum amount at or 10% confidence is, let's say that came out to 2.2 in the example Excel sheet that you shared. So maybe in a sense that we can kind of consult or guide the client that, okay, this is the maximum drawdown which you can go to, and let's say you can compare it to your price that you're paying. So let's say in the sheet right now, let's say if I see row number S6, which is 2.2, for example. So it's at 10% confidence level. Okay. So since we are looking at the confidence levels, but then we can in a
is for year one. NPV is 290.
Correct. NPV is 290. Since we are looking at it at a confidence level, but my point is that like we did the mean median mode, we can also know the maximum drawdown. That is the worst case scenario. That in my case, the worst case scenario is 257.3, correct? Lowest NPV is the worst case scenario.
Correct.
Maybe in a way we can guide the client as well that, okay, this is the price that you're paying and this is the worst case scenario. So maybe based on that, based on the max drawdown, you can take a decision, right?
Absolutely correct. See, essentially what you're doing is, you are already suggesting to them, but we are only playing on 1 or 2, 3 parameters and doing a what if analysis and trying to come to a number, low and high value, right? So
right.
What actually we are doing in Monte Carlo, we are actually repeating exactly the same thing. Only difference here is we are doing an interplay of multiple parameters simultaneously, which otherwise is not possible. And we are saying that figuring out where does it fall, low and high, and then we are guiding. That's exactly what we are doing.
Right. Okay. Okay.
Yes, anything else? I know it's a tough session, probability, distribution, the keywords every time. So nevertheless, I'm assuming that a part of it is you'll have some confidence to start experimenting on this subject.
Sir, would you be sharing the last Excel that you were showing, or that
everything will be shared here? What will I do? If there are errors in that, you'll only have to correct it. Mostly there will be no errors. Anything will be shared. No data will be cut with me. Okay. See, please understand, most of the modeling we think we can, it's essentially how you interpret the data later and use it, right?
Right, yeah.
Start learning. End of the day, we all learn. All the data is available for everyone. Good to go.
Yeah, I think if we don't have any sessions, Bhavik, can I request you to take the vote of thanks, please?
Hello. Hello.
Yeah, Bhavik, go on.
Yeah. So thank you very much, sir, for this insightful session actually. And I'm very sure, in fact, I thought that we should have planned for more number of hours for this session. It is very helpful and you are being generous to share all the knowledge with all the participants. And thank you very much for coming on board. Over to you to take the proceedings further, Asim.
Yeah, I think Ganesh ji, it was a very exhaustive session, and as you know, you have rightly, what we had discussed, that we wanted the practical part more than the theoretical part, so which has actually adequately been captured. And so I think this should be good enough. In fact, incidentally, this would be our last session for this year, so I'm sure people will have quite a few takeaways from this, based on which we can plan for something for the next year as well. Yeah.
Fantastic. God bless you guys.
All right.
Thank you so much.
Thanks a lot.
Bye.
Thank you, sir.
Thank you.